Okay, I'm going to cover questions that are involved in chapter 3.2 and 3.3 homework to help you out. So, question 1, define in word mutually exclusive events. If you watch the video, you can understand that mutually exclusive events are events that cannot coexist at the same time, so they exclude each other. So those are let's say two events that they don't have any point in common. Okay. Next one. No common point. Next one. A coin is tossed and 8-sided die numbered 1 through 8 is rolled. Find probability of tossing a tail and then a number greater than 4. Okay, coin is tossed. So coin has two sides. So be it first one, be it tail, be it head. So it's gonna probability is gonna be 1 out of 2, right? Total two sides, it only one can happen. So the probability for coin, for tail, it's gonna be 1 out of 2, yes? And then rolling a number greater than 4. So total, it says 8-sided die numbered 1 through 8. So total we have 8. So greater than 4. We are interested greater than 4. Let me see. Greater than 4, it can be 5, 6, 7, 8. 4 numbers, right? 5, 6, 7, 8. It has nothing to do with value 4. It's just 4 cases. More than 4, it's going to be 5, 6, 7, 4. 4 of them. And so probability for die, it's going to be 4 out of total 8, which is going to be 1 over 2. Yes? Now, what is interesting, here the magic word, it says and, when you are doing some event and doing another event. So first event is tossing a tail. Second event is rolling a die. And they are connected, these two events connected between themselves with die, with the word and. So and in statistics, in probability, always convert into multiplication. So this is going to be probability of tail. We need to multiply by probability of die. So that is probability of tail and die. So this is going to be equal 1/2 times 1/2. And we get 1/4. Okay? Now, one thing you need to know, probability is not measured in a simple fraction, but it measured in decimal notation. Whoever doesn't know how to convert a fraction to decimal notation, you can open my playlist, basic math, and you can find it there. Among decimal notations and the fractions, there is how to convert. I believe that was in decimal numbers. I explained there, but you can find it, or maybe I'll put at the end of the screen that video. Okay, next one. Suppose 60% of kids who visit a doctor have fever, and 40% of kids with a fever have sore throat. What's the probability that kid who goes to doctor has a fever and, see here, magic, and sore throat? So fever and sore throat. So what do we have to do here? We need to find probability of fever, because we have and. Here we need to multiply by probability of sore throat. Yes? Okay, what's the probability of fever? 60% of kids who visit doctor have fever, so 60% is 0.6. Probability of sore throat, 40% have sore throat. We don't operate in the percentage, we convert into decimal notation. Therefore, this one, probability of fever and sore throat, is going to be equal 0.6 times 0.4, and result is 0.24. Next one, a doctor gives a patient 90% chance of surviving bypass surgery after heart attack. If the patient survives the surgery, then patient has 40% chance that the heart damage will heal. Find the probability that patient survives the surgery and the heart damage heals. So we have and, so as we know what we have to do, multiply, so probability of survive. This time I'm going to write down this way, and, because it doesn't matter which way, so both of them works. Heart heal is going to be equal. Let's see, probability of survivor. How much? 90%, right? Which is 0.9. And probability of heart heal is 0.4. So here it is, 90%, 0.4. So therefore, so here survivor and heart heal is going to be 0.9 times 0.4, and it equals 0.36. By the way, I'm going to post help for every single homework you have, including practicing problem for group activity and test. Therefore, I see you haven't done week 1 activity, so please do your best. You have their table, of Excel. I completed everything, and that should help your group activity 1 and test 1. But after that, week 2 and 3 and 4, it's going to be much easier, because you are going to have this homework like this one. I cover step by step and solving every single similar problem, so it make it easy for you, including practicing problem for group activity and test. Okay, question number 5. A standard deck of cards contains 52 cards. One card is selected from deck. Compute probability of selecting a 6 or 10. Now we are arriving to the area where instead of and we have or. Here it is. When you have or, you are adding these two probabilities. You don't multiply, you add. If it would be 6 and 10, then we would multiply. So let's see. Probability of 6. How many 6 cards in the card deck? 4 of them, right? So probability, because it's not asking what type of 6, so I'm just writing down probability of 6. Probability of 6 is 4, right? Total 4. 4 out of 52. Probability of 10 is 4 out of 52. Which means 6 or 10, so probability of 6 or 10, it's going to be equal 4 over 52 plus 4 over 52. Yes, it's going to be equal 8 over 52. 8 over 52. Let me clean this one right better, 52. Which is going to be equal 2 over 13. You reduce by 4. And 2 over 13, since probability has to be in decimal notation, will be 0.754. So which is 75%, almost 75.4% is a chance. If you randomly pick the number from card deck, it's going to be either 6 or 10. Next one. Compute the probability of randomly selecting 6 or 10 or 8. Now we have 6 or 10 or 8. We have the result for 6 or 10, right? 0. Let me write down bigger. 0.754. So 6 or 10 we already have. So now we need to add also probability of 8. How many 8 we have? Again, 4. So we have probability of 6 or 10 or 8. It's going to be 0.754 because 6 or 10. Here it is, we already have it. And plus 4 over 52, right? If you convert 4 over 52, that's divide by 4, it's 1 and 13. 1 divide 13 and you add 0.754. It is going to be 0.231. Let's be, yes, 0.231. Okay, so 23.1%. And lastly, compute the probability of randomly selecting an ace or spies. Now, we have 13, wait a minute, how many aces we have? We have 4 aces. But how many spies we have? So we are dealing with or again. How many spades we have? It's going to be 13, right? Because a spade, it's a type of card. Ace is there are only 4 of them. So it's going to be probability of ace or spade. It's going to be equal. Ace is going to be how much? 4 over 52. The spade is going to be 13 over 52 because there are 13 types of cards. So in the 4 types, so 13 times 4 is 52. So this is going to be here is one more thing. Look here, because we have ace can be spade also, right? So one card is going to duplicate in end with ace and with spade, right? Therefore, we are going to subtract 1 out of 52. If you watch the lecture, it will be clear for you. I clearly explained there. So this is going to be equal 16 over 52, which is going to be equal 0.308. Okay? Moving to question number 6. The number of responses to a survey are shown in the Pareto chart. Here is Pareto chart. What's the difference between bar chart and Pareto chart? It's the same bar chart, Pareto chart, with the difference. Pareto chart is always placed in the descending order. So start the maximum and then going to minimum, while bar chart is placed the way it is, in the order you receive. So the survey asked question 551 adults. Yes, 551 adults. How much they trust social networking websites with their personal information. Find the probability of randomly selecting person from sample that meet each category. So, A, trust social networking website a moderate amount. So a moderate amount, so it's an A. Oops. It's an A. I'm solving probability of moderate. It's gonna be how much we have moderate right here. And right here, 143. 143 over 551, which is gonna be 0.2, which is 20%. B, trust social network website completely. This is supposed to be C. Social network website completely. How much do we have completely trusting? C, here it is. 32, right? 32 probability trust completely. 32 over 551. And that's going to be 0.058. So completely trust only 5.8%. We need to multiply by 100, right? Meaning multiply by 100, that means we are moving to the right by 2 positions, 5.8%. C, trust social networking website a lot or completely. Pay attention. Or, so here we have addition, right? So it's going to be probability of A, trust a lot, or completely, or C. So A, trust a lot, it's going to be 35 over 551. And C, we already know 0.058, so we don't need to go through calculation again. So this is equal 0.064 plus 0.058. We are getting 0.122. Next, D. Does not trust social networking website at all. So does not trust. Or only a little. So it's going to be probability not at all. That's going to be N. Here it is, N. And only a little, N and L, 167, 165. Okay. L or N. So L, we have 165 over 551 plus 167 over 551. And that's equal 0.303 plus 0.299. Result is 0.602. And always pay attention what in your problem it says at the end in parentheses, round till how many decimal notations. Okay, moving to question number 7. The table below shows the number of male and female students enrolled in nursing at university for certain semester. A student is selected at random. Complete part A through D. A. Find the probability that student is male or, which means we are going to have addition. So student is probability of male or nurse, nursing major. Okay, where is our male? Right here. Total is how much? 1108, 1108. Out of grand total 3536 or 3536 plus nursing major. Nursing major is going vertically. Nursing major is 2742 out of grand total 3536. And we are getting, by the way, look here, males is going all the way like this, right? And nurse goes like this. Yes? Let's do this way so it will be clear. This is male. And now let's go with nurse. Oh, that's, we are taking, did it ask nursing? Yeah, ask nursing, and I took non-nursing. Hold on, let me fix it. Here it is, nursing. Okay? So, which means it's here, it's going to be 794 total nurses. And look what is interesting. 94 is similar as the previous problem. Is duplicated with males and then nursing majors, right? So it's only one element duplicated. Therefore, we need to eliminate that one element minus 94, right, over 3,536. We understand? Because 94 are among males and 94 among nursing also. So intersection, we need to subtract, otherwise it will duplicate in male and in nurse. So once I subtract, I'm going to get and convert into decimal notation, I will get 0.511. All right, next one, B. Find the probability that student is female or not a nursing major. Now this time not a nursing major. Okay. Female or, which means we are going to add them, right? Not non-nurse. Let me put this way. So female, what's the probability of female? It's going to be 2428. Over 3,536, right? Over grand total. And non-nurse, it's going to be 2742 this time. Yes? 2742 plus 2742 over 3536. And do we have here intersection? Yes, we do. It's going to be this one. Female. And we are interested in non-nursing major. So if I provide, let's say, blue line, so it's going to be this one, see? Repeating with female case and non-nursing major. So I will need to subtract 1728 or 1728 to read and 3536. and this is going to be equal 0.973. Okay? Okay. See? Find the probability that student is not female or nursing major. So, probability, not a female, or, again, or, which is we're going to add nurse. This is going to be equal 1108. Where from I got 1108? We have total female and male. If it's not female, that means it's male, right? And total of male is 1108. Here. Over 3536 plus 794 over 3536 because nurse major. Total nurse major 794. Now, what do we have here? Male, again 94, it's gonna overlap, right? It's light blue and yellow at the intersection because we are dealing with non-female, which is we are dealing with male, and we are dealing with nurse major, which means 94, it's gonna again be subtracted. Minus 94 over 3536. And result is 0.511. By the way, I'm rounding till 3 digits. And the last one, it's a question. Are the events being male and being nursing major mutually exclusive? No, from this table, it's not. Because male can be nursing major also, 94. 94 students are male and nursing major. So this answer is going to be no. 94 students or whatever is male and nursing major. Okay. Approaching to last question. Let's take care of this one. The table below shows the result of survey that asked 1065, it's right here, adults from certain country if they would support a change in their country's flag. A person is selected at random. Complete A through D. Okay, we are patiently going to answer all 4 questions. Question A. Find the probability that person opposed to change or female. So who is opposing? How many total opposing? Look at the table and tell me. Oppose or female. So of course, oppose 617 out of grand total 1065. And then plus, how many females we have? 555, right? 555 over 1065. Now, if oppose goes vertically, yes, and female goes horizontally. You see 291 is intersection, so we need to subtract because 299 is duplicating because it counted and in oppose and in female. So 1065 it's going to be 0.827. Next, B, find the probability that person support change or mail. Let's see. Change or mail. We'll find out. Let's go back to table. Change, how many support the change? Here it is, the word support, 413. Since they have word support, let me put also support so it would be clear. 413. So 413 over 1065, or how many males we have here? 510. And obviously we are going to subtract 172 because male and support, right? Overlapping 172. And that is equal 0.705. Okay, moving to C. Find the probability that person is not unsure or is female. Okay, what means is not unsure? Where is our unsure? Here. If it says is not unsure, that means complement. Complement of unsure is going to be support and oppose, right? So there are two ways. I either can add support at 413 plus 617 and divide by 1065, or go nicer way, 1 minus 12 over 1065, right? Because it's a complement. It's going to be equal 1 minus 12 over 1065, because there are 12 right here, unsure and male. So this is going to be equal 1053 over 1065. Subtraction of fraction. Go to basic math and look how subtract fractions. And that is equal 0.989. Right? And from here, probability not unsure or female, it's gonna be equal 0.989. And indeed, let's go back and look. We subtract 12 over, let me rewrite it clearly. We subtracted 12 over 1065. What is 12? We subtracted. The 12 is unsure, and we need to subtract, that is male, right? Not unsure, minus 12, that is unsure, and male, opposite complement to female. And therefore, it's going to be equal 0.989. Now, in the D, last question, are there events being male and support mutually exclusive? Let's see. I marked down here 172. Male and support. Do we have it? Yes, we have male and support, 172. Therefore, it is not mutually exclusive. They can coexist. Okay, and in my next video, I will do a problem similar to your homework with combination and permutation. Okie dokie. If you like the explanation and this format, put their like so I will know and keep going this format, okay? All right.